Alright guys, welcome to this page of the notes. What we're doing is we're working on that second objective, which is solving rational inequalities. We do it by following 4 steps. Hopefully at this point you're getting kind of comfortable with those steps. So let's go ahead and do one more of these together, just to kind of make sure we really solidify this idea with you guys here. So here we go. Step number 1. The excluded values. So I got to figure out what gives me division by 0. I can do that by setting x minus 1 equal to 0. I get x equals a positive 1, which makes sense. You could look at it and know that, and that will be our excluded value. X cannot be a positive 1. If it were, 1 minus 1 is 0, and you can't divide by 0. So there's my excluded value. X cannot be 1. That's step number 1. Step number 2. Step number 2. Okay, here we go. Well, what I'm going to do is actually I only have 2 denominators. I have x minus 1, which is its own factor, and 6, which I know factors into 2 times 3. But you have to keep each factor the same, the number of times it appears. So I'd have to keep the 2, I'd have to keep the 3. So anyway, you wind up with 6 x minus 1 as your LCM. So my LCM, 6 times x minus 1. And let's go ahead and solve the related rational equation. So I'm going to have 6 times x minus 1 multiplied by 1 plus 6 times x minus 1 multiplied by 5 over x minus 1 is equal to 6 times 6 times x minus 1. And let's see what happens here. Nothing cancels there, but 1 times anything is itself. The x minus 1's cancel here. 6's cancel here. Fantastic, here we go. So I have 6x minus 1. And then I'm left with 6 times 5, so 30. And then I'm left with 7 times x minus 1. Let's do the distributive property to see how this goes. I wind up with 6x minus 6 plus 30 is equal to 7x minus 7. Interesting. Keep going. We need to get the x's on the same side. So 30 minus 6, of course, would be 24. So let's do this. Let's do, I'll show these steps. Plus 24. All right, I'll subtract the 6x to this side. I'll add the 7 to this side. So I have 24 plus 7 is equal to 7x minus 6x. And so what I wind up with is, what is that? 31 is, okay, so I get x is equal to 31, and there is my answer from step number 2. So now remember what we do in step number 3. I've got two I got 2 values. I've got the one from step 1, which was 1, x can't be 1, and I've got the value from step number 2, which is 31. So we'll go ahead and split a number line. Those are really, really far apart. So here's what I'm going to do on my number line. We'll go, and then we're going to skip a whole bunch and finish it off there. All right, remember, x couldn't be 1, so we will have negative 1, 0, 1, 2, skip a whole bunch, and then wind up with 29, 30, 31, and 32. All right, we divide this guy up into the 1 and the 31. Those are going to represent splitting my intervals. Careful though. This is the first time. Go back and check the problems we've done. This is the first time we've come across one of these ones where we're solving an inequality where the inequality is less than or equal to. Remember, I now need to consider the inequality, and it is less than or equal to. So what winds up happening is instead of an open circle on 31, I need a closed circle on 31, which means whichever direction this goes, either these guys in here or those guys out there, 31 is included. It's part of the solution region. So here we go. Let's go ahead and test some of these guys. I would test 0, x equals 0. I would test x equals 2. And I would test x equals 32. If you do that, plug a 0 into the original problem. Let me write the original problem for you. It was 1 plus 5 over x plus 1 less than or equal to 7, 6. Actually, this isn't that hard. Yes, yeah, great. Wait, did I do that? Oh, hold up. So, yeah, there it is. Sorry, I wrote it wrong. -1. There we go, that makes more sense. So here's what happens. If I plug in a 0, that means that I have 5 divided by a -1, which of course is -5. So 1 minus 5 is -4. Now, is -4 less than 7/6? Well, absolutely. -4 is negative, 7/6 is positive. Negative number will always be less than a positive number, so that's true. And these guys are part of my solution region, everybody in that direction. Let's go ahead and do a 2. If I plug a 2 in there, that's going to leave me with a positive 1. So I have 1 plus 5, which is 6. Is 6 less than or equal to 7/6? Definitely not. 7/6 is going to be like 1.3 something, I think, something like that. Anyway, it's a number not much bigger than 1. Is 6 less than something, 1 point something? Well, no, definitely not. 6 is way bigger. So that's, oh, that's my highlighter. That's false. And then we go ahead and check the next one. I go ahead and plug a 32. Plug a 32 in right there. What you're going to wind up with is 1 plus 5/31, which will turn out to be a number that is less than 7/6. It is less than 7/6. So everybody in this direction works as well. But remember, because my inequality is less than or equal to, that 31 is included. So here's what I would actually do as my interval notation. I would write this one in interval notation. We will have negative, let's see here, oh, that's ugly, hold up. That's a better parenthesis. Negative infinity to positive 1, not included. It's an open circle on 1, 1 is not included, union. And then it's going to be, right, and again, why is 1 not included, right? How do I know? How do I know this one's included but this one isn't? Remember how we got this value. If you include 1, if you put a bracket around 1, that means 1 is included. But if you plug a 1 in here, 1 minus 1 is 0, and you can't divide by 0. So that's why 1 has to be excluded. It's not a solution. It's not part of the solution region. So use a parenthesis just to tell you you can't use 1. You can use anything less than 1, but you can't use 1. However, 31 is a closed circle. It is included because it's less than or equal to. So we use a bracket. 31 is included. You can use 31 or anything bigger than 31. And that is going to be the domain of this rational inequality. All right, guys, I really hope you enjoy doing these rational equations, rational inequalities. I think it's a lot of fun pulling that LCM from earlier in the chapter and using it to help us solve both equations and inequalities. And not only that, I really hope you've enjoyed Chapter 8, sort of these rational functions. There's a lot of really awesome algebra going on here in Algebra 2, and not to mention all of the graphing we did with these rational functions and the super interesting characteristics that show up in there. I had a great time going through rational equations, expressions, and functions with you. Can't wait to see you next time. We'll see you out there. Bye.